Okay, confidence interval. Part 3. Okay, now I want to pick up from where we left off. Looking at the Price is Right gauge, how that guy literally barely made it, because if you remember correctly, his score was squeaked in at that point. We can kind of see it with this red on black, which we know is not very good. Okay, and remember what a confidence interval is saying. It's saying that we are 95% confident that the true mean value is going to fall within that interval. Okay, we can never say, and this is important, you may want to know this, we can never say 95% of the time. Okay, because 95% of the time implies what? The probability of success. Now I want to jump down to look at problem number 12, and we worked on this today in class, in which here, as we say, it's normal population, which we love. Right here, how confident. We have 25 SRSs, and this is a very generic situation. Okay, and I believe I mentioned this in the last video, so if I'm being redundant, all I can say is, okay, sorry. Okay, so here's sample size 1, sample size 2, sample size 3. So as we have done this today, working with that applet, based on the picture that you guys have, 100% of those 25 samples contain that true mean proportion. But if I had 2 of them right here, what did they say with the applet that we were doing? That it's 2 hits and 20 out of 25. Terrible marker. Okay, now let's continue on to page 4 of your notes and look at problem number 14. And when you look at 14, read over it, but please recognize you've got to go back and look at your problem number 10. So pause. Okay, now problem number 10 gives, we don't know what the point estimate is, but it gives us the interval. And just to remind ourselves, if we have the interval, the two extreme values, the highest and the low, to find the point estimate, all we did was take that interval and divide by 2. So the question here, we were looking particularly, that is the math behind it. I just wanted to throw that in. But as we look at the scenario, because the question was, would you like to lose weight? Okay, so this is a Gallup poll, and they're the polls of polls. They're the king of polls, a 3% margin of error. Okay, so just like that presidential election that's currently going on, remember a margin of error is that they give you the percentage, but you've got a little fluctuation, plus or minus 3. That is the margin of error that they're referring to here. So the question, what other potential source errors are there? Okay, well, the bottom line is somebody asked me if I want to lose weight. Of course I'm going to say no. Are you kidding me? Of course I'm going to say yes. It's response bias. Who's going to say no? The people who say no are those people that are 5% body fat. I actually know some of those people. They're disgusting. But anyway, the bottom line is most people have a bias because most Americans especially, we're not comfortable with our weight. Okay, so response bias. Okay, now please take a moment to read over problem number 18. And please notice for 18, you've got to refer to problem 16. Okay, so problem 16 is referring to Facebook information, how teenagers give false information on their profiles. So here was the confidence interval, okay? And remember what this is saying is that I am 95% confident that the true mean value of teenagers that give false information on their profiles is going to lie between 0.120 and 0.297. And actually in this particular case, it's the true mean difference, because what they're looking for is the younger minus the older. And you've taken a moment to already read this, and the question for 18 is, does the confidence interval give convincing evidence of a difference in the population proportion of the younger and the older? And the answer is yes, it does, because when we subtract the two, okay, which they've done right here, 0 is not contained in this. So it's kind of like what we were doing today on the statistical applet. Okay, we have, this is our interval. And I don't think they gave me the mean value, so it's going to be in there somewhere. But here is this is the true differences, younger minus older. And if we're saying that there's no difference, that's why it's going to be equal to 0. So that's going to be out here somewhere. So this is not captured. You see this sometimes in your interval. So yes, there was no difference, because that difference of 0, which means no difference, is not captured inside of that interval. Okay, now I want to stop and talk about your test, or I should say your quiz. I said I was going to just infuse it somewhere in the middle of the video. Now's a good time. So as we continue going through this video, there's a couple of things that you need to know for your upcoming quiz. How to draw. When I say draw, I mean physically draw like you did today. A 70%, 80%, or 90% CI, given a sample size, SS, of 10. Okay, what not to say. I mentioned that already. How do I decrease the interval? Well, that was discussed, or you should have determined that as you worked today. Okay, give an example of a margin of error. Well, you can give one of the ones from the textbook. You can give one of the ones that I mentioned in terms of the presidency, or you can make up your own. Okay, in layman's terms, what is a confidence interval? So don't go and say we are 95% confident that the true mean value. What the heck is that? They're not a layperson. You tell that to your parents, they'll go, "What do you mean you're confident? How are you confident? Why are you sure about this?" And you go, "No, Mom, no, Dad. I'm not sure about it. I'm saying that I've got here some confidence, some intervals. I've got some range of values, and I feel that given many, many, many samples, that 95 out of 100 are going to capture the true mean value." And they'll look at you and go, "Okay, it's been a while since I've taken statistics, so I'll just figure that you actually know what you're talking about." That's not layman's terms, what I just said. Okay, layman's terms is what we've been talking about in class, and you should have been talking about in your group. One more thing that is going to be on the quiz is what I'm about to pull up on the statistical applet that I put in your sent to you via email. So I'm going to show you a few things, and then you might want to play with it yourself. Now, if you look at this, this is slightly different than we did today, but let's equate this to the Reese's Pieces situation that we did. Okay, with the Reese's Pieces, 45% were orange, if I remember the scenario correctly, but let's infuse the new information that we have. Now we've got confidence intervals. I'm saying that each bag of candy holds 30 pieces of candy. I have no clue. I don't eat those. I eat the Reese's peanut butter cups. So if I'm wrong, okay, fine, I'm wrong. Okay, so here's one sample, and I like this one better than the one we had before, because look at this. Here is showing the point estimate, which is right here, that 0.267. And then it's showing here the margin of error, which is 0.161. Here's the low end, and here's the high end. Okay, so this is of one sample, but let's notice here's the true mean value. Oopsie, get off that. Stop it. Okay, the true mean value is 45. So here, this is a bad batch. If I'm a person that loves my orange, I'm going to be upset. Let's look at another one here. Oh, finally. Look at that. The mean of that particular batch is 40% with the margin of error of 0.18. So remember, here's the 0.4 minus the 0.18, and here's the 0.4 plus the 0.48, and that would give me my confidence interval. Okay? Here, as I do another one, every time I click, it does that. Okay, let's pay attention as we see numbers 2 and 3, samples 2 and 3. So remember, this is one bag, this is a second bag. It does capture the true mean, which we said 45% of the candies. So now let's just look at a sample of 27. Actually, it's 28 because it's the 25 that I added plus the 3 from before. And as I try to shrink this a little so you can see the big picture, here it shows us that we have, let's look at the terminology that we looked at on today with the activity. We've got 25 out of 28 hits. Okay, so first of all, let's go with statistical jargon for a minute. We are 95% confident that the true mean value of the percentage of oranges in the Reese's is going to lie between the interval, and let's just look at one interval right here, 0.5 plus or minus 0.18. So you can leave it like that, but the reality, we do need to do the math. So what is that? Between 0.32 and 0.68. So looking at this first set, we are 95% confident that the true mean percentage of oranges that are in this bag of Reese's with these bags is going to be between 0.32 and then 0.68. Okay, so look at all of these that capture, but like it says right here, I've got 28 total. I've got 25 hits. Where's that extra one that it did not make? I don't see it. Let me just reset and then do it again. Okay, so right here I've got 23 out of 25. So I can see here's a bad batch because if I'm a person that likes orange, I'm not happy. Here's another batch, not happy with the lack of orange. Okay, so but look at the green, 22 out of the 25 batches do capture the true mean percentage of 45% orange in their bags. So as I flash this at you again, this is the stuff that you need to recognize. And then as I add the component that I just mentioned, the point estimate, just writing down one that I don't remember them, to be honest. I think it was 0.5 plus or minus the 0.18, knowing that this right here, you can't see it, you can't see it. There we go. Knowing that this is your point estimate and knowing that this is your margin of error. Now, as I wrap this up, there's a couple of things I need you to remember. When you give the interval of x bar or p hat, basically it is going to be the midpoint that is going to be the point estimate. Okay? If the true mean value or mu or p, which is the true mean value, is not captured within the interval, it is not good. Remember how we talked about with the trucks and the trucks emission? Well, if the emission was 1.8 and it's outside of that, they're going to have to do a recall because EPA is coming after them, or it could cause damage to the customer because if the emission's not coming outside of the car, potentially it can go inside of the car, with the understanding that I truly don't know much about that stuff with the cars. But the one thing I do know, it emits smog and EPA will come after you. Okay, so your notes should be caught up. Make sure your homework is caught up and just prepare yourself for the quiz on Tuesday. 3 days, just saying. Okay, have a great 3 days and try not to study at the last minute like Sunday night at 10 p.m., people. Not good. Have a great weekend. Bye-bye.